The first lesson in differential calculus, we have to deal with the word tangent. So what is tangent? The word tangent is derived from Latin word tangens, which meaning touching. So thus a tangent line to a curve is a line that touches the curve. So the definition of tangent is a tangent to a curve is a line that touches the curve. A tangent line should have the same direction as the curve at the point of contact. So let's say we have a blue curve. What is a tangent line? So tangent line, I can give you an example. So tangent line, I can draw a line right here. I can draw a point right here, right? So this is a point. So at this point, the tangent line is horizontal. You don't need to know why that is a horizontal. At this point, I am telling you that at this point, there is a horizontal tangent line. At this point, there is a horizontal line. At these 2 points, the slope of the tangent line is 0 because horizontal line has 0 slope. If you take a point right here, what is the tangent line? The tangent line looks like this. It's a line that touches, again, touches the curve one time at this point. And then if you take a point right here, this is the tangent line. It's a line that touches the curve one time. So at this point, what is the slope of this tangent line? The slope of this tangent line is positive because the line is increasing. The slope of this tangent line is negative because the line is decreasing. Oh, speaking of straight line, how do you find the slope of a straight line? So speaking of the slope of speaking of slope, how do you find the slope of a straight line? So let me give you an example. What are the basic ingredients to sketch a straight line on xy plane? The answer is you need 2 points. So we have 2 points. Let's say we have 2, 4 and 4, 8. So we call this point 1 x1, y1, and we call this point 2 x2, y2. To find the slope of a straight line, so the slope is equal to m is equals to y2 minus y1 divided by x2 minus x1. And then you plug in, so you have 8 minus 4 divided by 4 minus 2. So that is 4 divided by 2. So the slope of this straight line is equals to 2. What is the slope of a linear equation? That is y equals to mx plus b. Mx plus b, so we have m. This is my m. So y is equals to 2x plus b. But I only have a slope, I don't have a y-intercept. So let me just get a point. So my point will be, I'm trying to make a point. So let's say this point, 1, 6 is a point on the line. So that means the line will go through this point. And then you just plug in x and y. So you have 6 equals to 2 times 1 plus b. So b is equals to 4. So now we have y equals to 2x plus 4. This is a straight line, right? The slope is equals to 2. And then the y-intercept is 0, 4. Y-intercept is a point on the y-axis. But the thing is, what if you have a parabola? So what if you have a parabola? So what is parabola? So let me remind you that parabola is a curve, right? So you have a parabola, and then this is a parabola. It's not a straight line. Not a straight line means the slope is changing all the time. If you pick a point, this point and this point, they don't have different slope. This point and this point have different slope. This point, the vertex at this point, they don't have the same slope. So how do you find the slope if the graph is not a straight line? That is what we are trying to find out in calculus. What we are trying to do is, I want to find an equation of the tangent line to the parabola y equals to x squared at the point 1, 1. So this is my graph. So let me make the graph bigger for you. It's easier for you to see. I have a curve. Y equals to x squared. It's a parabola, right? The vertex is at 0, 0. I have a point at 1, 1. This is a point at 1, 1. I am trying to find the equation of the tangent line. What is the tangent line, by the way? At this picture, the tangent line is this red line. So this red straight line is a tangent line. This line touches the curve one time. Okay, and then how come there is a blue line right there? The blue line is a secant line. Okay, the blue line, the blue one right there. So let me give you an arrow to point it out. The blue line is a secant line. What is a secant line? Secant line means cutting. So the idea is we draw a curve. I want to stick with the color, but I cannot do black on my paper. So let me pick a color. Let's pick a green one. So we have a parabola. And then I have a point. I have a point right here. I am trying, this point is 1, 1. The way I do this is I start with a secant line. So the secant line, let me stick with the blue. I am going to draw a line that cut the graph 2 times. So one in here and then one in there. This is pretty hard to draw. So let me see. How do I get this? Okay, I figured out a better way to do this. So let me go ahead and erase this point. And then I put a point right here. And then my secant line, I am going to draw a line that cuts the graph twice. So do you see this? I have one intersection at green, one intersection at blue. So this blue line is a secant line. What is a secant line? As in Latin, the secant means cutting. This blue line cut the graph twice. Or you can say that the blue line intersect the parabola twice. One point at 1, 1, 1. And then what about this point? This point, I'm going to call this point Q, x, x squared. So now I have 2 points. Point P is 1, 1. And then point Q is x, x squared. Why? Why x, x squared? It looks like they are from nowhere. Okay, at this point Q, I don't know what x is. I just pick x is just an x value. At this point, x is just an x value. How do you get an x squared? You plug in x into the parabola, right? So to get the y value, all you have to do is you square the x. So that's why the y coordinate is x squared. So basically, I have one straight blue line with 2 points, 1, 1, and x squared. How do you find the slope of this straight line? Again, the slope of a straight line. Easy. I learned this in elementary algebra. So this is how I do it. The slope is equal to, or you can say the slope PQ, the slope of the line PQ. So that is equals to y2, which is x squared minus y1, and then x2 minus x1. So that's how I do it. And then we have a table. When x is equals to 0, what do we have? We have 0 minus 1 divided by 0 minus 1. The slope is equals to 1. When x is 1.5, you plug in, when x is 0.5, you plug in 0.5 to x squared and x, you get a 1.5. And then you do the same thing for the rest. I leave one blank right there when x is equals to 1.5. So let's fill out this blank. So we have 1.5 squared minus 1 divided by 1.5 minus 1. That is what happened when x is equals to 1.5. The answer is this is equals to 2.5. Do you see any patterns in here? Why do I need to bring this table up? What is the first point that I pick? The first point that I pick is a 0. When x is equals to 0, this is equals to 1, and then 0 0.5, 0 0.9, 0.99, and then 0.9999. This is 1, right? So to get this makes more sense, I am going to draw a number line right here. I am going to put a 1 right in the middle, and then this is a 0, this is a 2. Where is 0.5? So we have a 0.5, right? And then a 0.9, and we have a number that is closer to 1. This is 1.001, 1.01, and then we are getting farther away from 1. So let's change colors for this. The 0.99 and a 1.001 is actually a number that is right next to 1. So we have a number on the left side of 1, we have a number on the right side of 1. I want you to make an observation. What happens when x is approaches to 1 from the left side of 1 and from the right side of 1? When x approaches to 1 from the left, we are looking at the 0.99. The slope is very, very close to 2. Let's look at the other side. When x is approaches to 1 from the right, what is the slope? The slope is 2.001. So to me, the slope is equals to 2. So what do you see here? So what I see is as x approaches to 0, x approaches to, not 0, x approaches to 1 from the left, the slope approaches to 2. What about x approaches to 2 from the right? Let's make this, let's do some simple. Approaches to 2 from the right, the slope approaches to 2. What is x approaches to 1 from the left and from the right mean? X approaches to 1. X is what x? X is here, is the x for point Q. As x approaches to 1, this is, you have to use your imagination. As x approaches to 1, just picture this in your mind. You have a point Q, right? As x approaches to 1 from the right, this point Q is actually getting closer and closer to point P. As x approaches to 1 from the left, this point, we pick another point right here, and any point on the parabola. So they pick this point. As x approaches to 1 from the left, this point is getting closer and closer to 1. So what happened is, we draw the graph one more time, the green curve. What happened is, we draw a green parabola, and then we shoot a line, secant line, through the point. So this is a secant line. We shoot a secant line through the parabola, and we have two intersections, point P and point Q. Okay, I am not interested in the slope of this pink line. The pink line is a secant line. What I am interested is the slope of point P right here. I want to find the slope of point P. So what we are trying to do is, we start from scratch. I shoot a line through the parabola twice. We have a point P and a point Q. And then I want to shrink the distance or minimize the distance between P and Q. So as you minimize the distance between P and Q, what I observe from the table is the slope is getting closer and closer to 2. So what we are going to say is, at this point P, the slope of the tangent line, which is not the pink line anymore, the slope of the tangent line, let's use another color for comparison. The slope of the tangent line, this white line, touches the parabola one time at point P. The slope of the tangent line, the white line, at point P is actually very close to 2. Again, we start from scratch. We shoot a line through the parabola twice, and then we minimize or shrink the distance between them. That means I am going to take an x value that is closer and closer to P to see what happens. The result tells me, the table tells me, as x approaches to 1 from the left side or from the right side, the slope is equals to 2. So now we can say that the MPQ is equals to 2. We just did it. Parabola is not a straight line, it's a curve. I start with a secant. I have 2 points, and then I minimize the distance between them. I got a slope. The slope is equals to 2. This is how I find the slope of a curve using secant line. Okay, let's take a look at the summary. So this one, I have 6 pictures. let's take a look at this one first. This one, what do you see here? We have a parabola. We have a tangent line, which is the red line. We have a secant line, which is the blue line. So we start with a blue line, point P and point Q. So point P and point Q right here. So let me take a darker color. So point P and then point Q. And then we are trying to shrink the distance between P and Q. So now, this time they are closer. This time they are even closer. Now, picture this in your mind. I need you to use your imagination. Do we agree that when when Q is getting closer, closer, and closer to P, the secant line actually becomes the tangent line? When these 2 points are so close, the blue line is very similar to the red line. So as P and Q are getting closer and closer, the tangent line, the secant line is no longer intersecting 2 points. The secant line is now intersecting 1 point because the secant line eventually becomes a tangent line. So this one is Q approaches to P from the right. The other one is Q approaches to P from the left. Q approaches to P from the left. So we have point P and point Q, and then we make them closer, and then we make them even closer. So as Q is getting closer and closer to P, closer to P, so this line is actually going to be very similar to the tangent line. So again, the concept is we start with two intersection, 1 point and another point, point P and then point Q. We make P and Q closer, and closer. Eventually, the secant line will become just a tangent line. As P, picture this, P shift over to Q. Do you see that these 2 intersections, they actually becomes 1? So we have one intersection. One intersection means this straight line is touching the parabola exactly 1 time. So that straight line is called a tangent line. So this is the idea of tangent line and secant line. Okay, let's pause the video right there. So I will give you an example in the next video.